Hi here, this is pretending to be an update of condensing all the information I got about the controller, about the Slasher controller and the Anaheim controller also. Something to say is about safety. I think mm, it should be take care some in account about the safety because uh, in case of rotor brakes, shocks, so better regulate the input of voltage, not making it suddenly different, make it smoothly change. Uh, then about the spark uh, carbon connector, those brushes, right? The the carbon made brushes connection of the slasher. I think they may make rings of fire and damage the plastics of the slasher itself. So um, I thought about 2 points of this. It's make it about of other material instead of plastic, like clay, sand clay, or something that's hard material that won't burn. Maybe go a little fancy on that if you know some rubbers or other fancy plastics that won't get burned or melted. And about the spark itself that happens there, I think if that is the cause of the damaging the not conductive material of the slasher, maybe we can apply a vacuum into it so there won't be spark, right? If there is vacuum, there won't be spark, and maybe the burning is reduced. So other thing is that those carbon connectors should be always strength to the against the slasher, right? Maybe with kind of springs, something you have to tight some once in a while, maybe, or change, replace with the new ones, right? Some new carbons. That's something to take in account too. And if in the case you make a vacuum into it, I thought about having a total transparent enclosure box, a plastic box, right? A cover, and the motors to make it vacuum, so everything is visible, right? It's a transparent plastic, so to keep everything visible, uh, and the motors should be 24/7 working to make the vacuum, so they should be designed to that purpose, right? To run 24/7. And maybe if there's a lot of work to one motor, maybe go two vacuum motors and sequence them to be on and off once some for a while. So that was about the controller. Other thing is I found out about the sensors of the Anaheim because I am trying to find I was trying to find exactly the uh, exact exactly the point where is the most efficient point for the motor to run in relation of where is the legs position in relation to the poles of the rotor itself, right? Where is the best position relation one to the other for the motor to work more efficiently. And I haven't found it yet, but I think it's no problem because it could be found, right, with the prototype made up easily. So I want to just say some uh, some calculations, some searching I did to try to find this point, and it was also about how the Anaheim motor controller is working. And I started with this timetable, right? And something that was pissing me off is that why there was in two steps the same sensor connected when there was a new input signal, right? And after, with no new input signal, like it is the third step, the first one, the A was closed. Why, if here there was the signal, right? Here is no new signal, but this one got closed. So I thought that was that was pissing me off, and I think I found out why it is represented this way. And to that, I have here a little show. Let's turn this thing on. So here we have a rotor, right? And I found how many poles did it have, because playing with this is a chick magnet, right? Playing with this around here, I was trying to find, right, where did the how many poles did I have here, but and now I realized it wasn't 3 pole per each stack of magnet as I thought. I found a way to just find how many are they, or how many does the Anaheim controller says it has, right? And I made it like this. Here we have a Hall sensor, right? Is just that this at the top, right? All this is foam stack and shit and the connection, so that doesn't matter. Well, you can see that red LED light of the board there. That will change when the sensor receives a signal. Here we have the chick magnet, right? And when the position, actually it's this sensor is looking down, actually, right, as you can slightly see. So as I pass through the magnet, you see the LED got off. It's not lighting anymore, and it doesn't turn on whenever I pass against the chick magnet again, right? But as you see, if I get close to the stacks of magnets, you can see it turning on and off. And this is how I found how many poles did I have per each stack of magnet. You can see I'm gonna wrap this through this stack of magnets, which I painted like more or less as you did. Here we get to the end of this one. It's lighting the LED. So now it's turned off. Here we have one change. So we have one pole. We keep on going. It turns on. We have another change. So it's the second pole. It keeps on. Now another change. That's the third one. Now another change. That's the fourth one, and we're arriving to the end of the stack, and that's the next one. So we have 4 changes per each stack of magnets, so we have 4 poles per stack of magnets that this controller is taking into account. Referring to this timetable, as you can see, once that LED is turned on, right, this sensor is no longer in the same position it was to get that respawn, to get activated, right? The controller received the signal, but the sensor is no longer in the position of which made that signal to be sent, and that was pissing me off. Why there was the sensor acting 2 times in different steps, right? I imagine that I couldn't figure out physically how the sensor was acting two different steps, right? That didn't make sense to me. Like, if the sensor is this peak here between legs, right? When the rotor passed, it's no longer in the same position. So why it keeps saying it's acting? And that's because it's the board itself which takes account the signal. The sensor keeps a gate open when activated in the electronics board setup until the next sensor signals, right? So it keeps it stills even if they are not suffering the physical force, even so they are away from the magnet, right? So it's the board itself which maintains the signal like open, even if the sensor is no longer in the physical position where the signal was sent it. So taking into account that, now it's more understand I understand better how this timetable was representing. And other thing I realized, then I was trying to find that exact position in relation with where there is the leg pointing and where is the best position of the pole to be against the legs, so it makes it work, right? To position the slasher controller in relation to that, so the leg is pointing right to the spot it was the most efficient spot position of the poles of the rotor magnet to get the better response of the motor, right? And trying to find that, I wanted to find where was the Anaheim controller uh, pointing when it received the signal from the sensor, right? So I found out like this. I made a drawing of it. Let's say that this gray line here is representing the magnets, right? The poles of the magnets, and the orange line is representing the legs of the stator, right? And those black points represent the ending of each of them, right? The ending of each leg or the ending of each pole, and the red points here between means the middle point, right, of each of them. And here with this pornographic looking pink arrow, I signal where the Hall sensor will be positioned, right? As you can see, I thought it was activated when there was a middle of a pole right between two legs, right? As you position your Hall sensor, right? You position your sensors here between the legs as this pig, right? And the pole, just the middle of a pole is pointing to it. So what to make these lengths of each of them, I made as follows. If we have 48 poles, right, I divided it between 36 legs, and I got 1 point never ending 3 period, right? 1.3 never ending. And then if we have the opposite, 36 legs divided by the 48 poles, right, we get 0.75. okay, those are ratio of percentage per length per unit, that each one in relation to the other halves, right? So we have 0.75 legs per each pole of magnet, and we have 1.33 magnet pole per each leg, right, in length. So I found out that as you can slightly see here, per each length of, let's say, this one, right, this leg, we have 0.75 of the length of a pole, and for the length of a pole we have 1.33 times the length of the leg, right? And I draw it in this paint program because I haven't got any better drawing program at the moment, just opening the grids here so easily, right? And the numbers I chose is 12 and 16, because as you can see, if we divide 16 between 12 points, right? So, 12 squares of these, which this drawing program allows, we have 1.33, which is our ratio. And if we divide 16 between 12, we divide 12 between 16, we have 0.75. So it made up the same ratio we had in the real relationship in between number of legs and number of poles. So we have here 12 squares per each pole and 16 squares per each leg. So we have the same ratio. Okay, so as you can see, it's positioned like there is half, just the middle point of the pole is between two legs. So here will be the whole sensor of the Anaheim controller getting activated, right, by this pole in this instant. So what can we see from here? We see we got the signal, so there is as it says, every time there is one phase which is receiving voltage, one which doesn't sucks or gets any voltage, right? It's closed, and one which is being sucked of voltage, right? Voltage comes out. So what can we see here is that I imagine this sensor is getting this, let's say, this phase activated, right? So it's 1 2 3, is this one is the same phase, right? 1 2 3, this leg is the same phase. So what I imagine is like this works when the leg gets fitted, right? So let's say this leg is getting fitted, this phase. So what will happen if we have the pole like this, right? The disposition is telling that if this pushes the rotor, this rotor will move to the right, will move clockwise, right? I represented it with this blue arrow, the direction of the rotation I think it will make. And then we will have this second phase that it's coincident the half of the middle of the pole with the middle of the leg. So I didn't point it where it will rotate, right? I thought this was set. I'm gonna speak more about this. And if this leg will get activated, it will, as is it just between this middle of this half of the pole, it will make to rotate in the opposite direction, right? So I signal it to the left, but we are pretending this rotor to go clockwise, okay? So this pole, this phase at the moment, will make the motor turn the other way. So what can we see here is that this gets repeated every time, okay? We see 1 2 3 1 2 3, it's repeating the same sequence. So uh, relating this to the timetable, I thought this was the positive, right? As it says, this was the set and this was minus, right? But I think I realized maybe I'm wrong, that thinking that just because that the phase which is getting feeded is the one which is making the motor run, right? So because I studied, I remember the Venturi effect of when I was studying compressed air, compressed air gases circuits, right? Compressed air circuits. And it was just the effect was that when there is a line and there is an opening point in it, you have flow into the line, right? And that open point experience a suck, a vacuum in that point because of the current flowing in the line. That's the way they make vacuum. Okay, you have a line which has a flow, and you open a point there, and what happens is that point, that open gate, experience a suck, and that's what is happening in the set point, I think, because I'm gonna make a little presentation with this my multimeter, right? This pissed me off too. I didn't thought the legs were connected to each other, even if they was a closed wire connection here, right? The three ends here, but I thought the wire itself was insulated. So as you can tell, they are connected, right, from each other. The thing is beeping and connected. Let's try to. I'm gonna try to leave one there. Sorry. To the end point, right, and here, right, everything gets connected, and also here, right? So this pissed me off because that was making a mess into my understanding how this motor could turn if each time one phase gets fed, the other ones are receiving the current too, right? Because I thought it was all sequence and all enclosed per each phase, but that seems to not be happening like this. So what about that Venturi effect is if all of this is connected to each other? What do we have here? We have a line, right, which is this entrance and the entrance and the out and the leaving point, right? The leaving phases. One turn goes in and goes out. So we have a line, but we have another phase between, which is experiencing that vacuum, which here calls high impedance. When the set point per each step, what happens is that if current flows into one phase and other of the three uh, is experiencing a sucking of voltage, so the current flows in by one phase and goes out by other phase. But what happens with the other one? It's like a line and another coil there, right? So flows one to the other, and the other one experiences like a vacuum, right? So because you have flow between one phase to other, and the other one is between, just there, and it is, I think it will experience a vacuum. So I think this maybe is what makes this motor turn, and not exactly as I thought, that the phase which was feeded was what the point where the motor was getting turned, right? So it can be that this vacuum phase, which is between the other two which are flowing, is in reality what is making this motor turn. I think we can achieve this with the slasher controller too, right? Is just adding another um, out for the voltage, instead only just the input of voltage, right? So it's pretty easy to be done, but with this I'm not sure where to position the coils, because as you see, as I thought, this counting that this leg, let's say this leg was receiving the voltage, right? This was where the time of this phase to receive the power. So I thought this was the time and the position which made the motor turn. As you can see, the middle of the leg is in this position in relation to the pole, right? So my physics understanding uh, told me that yes, this half of the leg should be near, close to the half of the pole to make a turn, right? To be for the poles to be stronger, right? To make a stronger response of the rotor. And here you can see this will be the set point, because there are one there are both coinciding on the middle point. So I think this will experience the vacuum, right? if, if this one is which experience the vacuum, or maybe it's this one which should experience the vacuum, and this one should be which the voltage is sucked out, right? That's what I'm not sure, but now that I see it, it could be that here we could have a voltage output, right? Because the pole is right on, and here if this one gets powered, so it makes sense that this will make it turn, right? And this one sucks voltage, so we get voltage because the half of them are coinciding here, right, on the middle. And then this coil is being having a vacuum into it, so we want the motor to run clockwise, so this pole will be sucked to the middle of the leg, right? So it helps the rotation too. This is something I'm trying to figure out exactly, as you see, and how this is working. But having a slasher that just gives a power in, I think that's the first step for me. I'm going to try to accomplish, just to have an input, and then maybe apply other one, just another couple brushes, so we have so I to get the voltage out, right? The current flowing out, and that's very easy to get done, right? But I still not exactly figuring out that position in relation to the rotation where it should be positioned. The rotor in relation to the rotor of the washing machine of the right. So the slasher position in relation to the washing machine rotor, but having the proper uh, I'm sure there is the proper sequence in that slasher, so it won't be any problem. that sequence just should be half of the pole, right? I think to get acting in half of a pole, right? So there won't be any problem instead of making it all around the pole per each slash, right? Where the power should go in or go out. I think that's the only mistake I can make. So I think gonna try with that. So I think that's pretty much all I had to say. Uh, that's a question. So I think if that set point here, which is telling that this says that no current flows into or out of this wire, right? But it doesn't means exactly that it won't make it turn, right? Because it is experiencing a vacuum into that coil. So I think it maybe could help it at least to turn, as my picture is reflecting right here. As I said, right, this point, this pole will get sucked, so to the coil. So I think it's pretty much information about how this works. Anything else? Give me a minute just to check. Yes, just instead of having a slasher, uh, let's say like this, with that timeline in between. So we will have to position just instead just one carbon. We'll have 3 for the input, and just you can put another 3 for the sucking, right? So in different angles from one to each other. So it's that's the positioning, right? Just in this or in this angle or whatever, that will change the sequence of each of them, right? So next step for me is to make all the drawings, the with all the measures, all the lengths, to send it to machinist and get it done. So that's next step for me. If there is anything to comment or to anything to say about it, I really I would like to hear it and comment or whatever. uh, I think this is all I had to say, right? So I don't know, for conclusion, I don't know exactly where to position the slasher, right? Uh, in relation to the rotor of the washing machine, right? But it will be easy if we can have here like a screw, right? Like a bolt, so you can loosen it and reposition this slightly and then tighten it again. So we can try different positions to achieve the best spot for the legs to act in relation to the slasher controller. Other thing was uh, sorry, what it was. Yeah, by tightening this to this is just very expensive. I think that tightening this shaft to a machine which could measure the torque um, of the system, it will be easy to get that spot, right? To get exactly that spot, or to tune the slasher controller to the most efficient point of positioning to make it work the most efficient way, right? Let's say if this motor was putting out, let's say 3, right? So by uh, repositioning it, right, rotating it and tightening it again, uh, there will be varying, right, the value. So then maybe we will get the better the better readings of torque or whatever, to find that spot and to really figure out how this motor is working. As I say, I'm not sure if it's only with the input of voltage of the leg how this motor is turning. Maybe it's half of the true, and the other half maybe it's that sucking coil, that sucking phase per step helps the rotation too. So I'm not sure I have all the full explanation, okay, but I think it's very accurate for now. I would like to hear if you have something to say about it. I think this is pretty much it. If there's something else to say, I will upload it. So see you next time, guys. Uh, catch you later.